Hello, and welcome to class number 7. In this particular class, we are going to explore some retiming. And just to give you a brief overview of the shot, basically we have this background plate, and it's been treated so that we've got some few fixes to get rid of some imperfections and so on right here in the script. And then what we have is the integration of something that might look somewhat familiar, which is these fairies. And if you were to see the original green screen, of course, this will probably jar your memory a bit, because if you look at this, you'll recognize this stage here, and of course what they had before with the warping and the rig and wire removal. But in this particular case, we are not going to focus on that because you have already been through that. So what I was going to do is show you the process of retiming these fairies as they fly. So if we look at the final integration here, they are integrated nicely in these little flower petals, and the idea is that they fly out of the shot at the end here. So let's take a look at the flip book. So here we have the slap comp of the two fairies, and they fly off at the end. And the client sees this and says, hey, you know what? These don't feel very natural the way they fly off. So can you retime them so they feel much more like they're flying off in almost a cartoon-like manner? And so when you look at it, let's focus on the screen right fairy here. Let's figure they're going to move at 100% speed up until about frame 1024, and then right before she takes off, so 1040 for example, from there to 1024 to 1040, we're going to run her at 40% speed. So we're going to slow her down considerably. And then from 1041 all the way out, we want to speed her up really fast so it looks like she just flies out of the shot, kind of like a cartoon, if you will. So we'll do that at 160%. So with that, let's get started and figure out how we would actually accomplish that. So before we get started, let me just quickly give you a real comprehensive overview of the script. Like I said, from here, which is this stuff here, this is the painted background that has some fixes to it. Then moving here, we have this fairy, which is comped over on top. And like I said, I've included the green screen, and I actually retimed it so that it would match, and reformatted and basically changed it up so that it was exactly the same. And the only reason for that we'll discuss a little later. And then here is adding the second fairy. And then, in both cases, we're adding something over on top of them to kind of hide them in, blend them into the background elements a little bit better. So now with that said, let's go ahead and focus on our screen right fairy, which is this one right here. So now that we can see our fairy here by herself, let's go ahead and start doing a retime with what we talked about earlier. So I'm just going to go ahead and get a retime node, and if you notice in the properties here, you have this speed channel, which is the default. You have this time warp graph here, but frankly this isn't going to be terribly useful because there's also a time warp node, which gives you the use of the graph editor to do, or the curve editor to do this exact same thing. And it actually, it's more effective in its UI for doing that. So we're not going to discuss any of that tab. But basically, to retime footage, if you want to do speed ramps, very specific time changes like what we discussed, so from 1024 to 1040 we want to move it at 40%, and then from 1041 to the end we want to move it at 160%. Now with that being said, you might in some packages keyframe this, but for this particular case it's a little bit more involved, and you have to do it a certain way for it to work properly. So that being said, the other thing that I want to discuss is that we have here our filtering method, and we're going to use nearest. And I'll kind of explain, the reason for using nearest is that this gives us a very clean frame, and it's not going to be changing the pixels any in retiming it. It's just going to jump to the closest frame that it's supposed to be at any given point in time. So with that being said, let's go ahead and set this to 40%. Now in this case, what you have to do, since we want to go from 1024 to 1040, we want that to be 40%, we need to set these frame references. Otherwise, it's just going to set the whole clip to 40%. So, and I suppose we could do it that way, but just to show you the functionality of these boxes here, we're going to go ahead and do it this way. So from 1024 to 1040, we're going to set that, and we're going to go ahead and set it to 40%. As soon as we do that, these numbers here in the output range actually change, and they show what the new calculation will be, where at 40% speed, running these almost 20 frames will actually make it land on 1066. This is important for what we're going to do next. So I'm going to just go ahead and label this 40%. So now with that, let's go ahead and get another retime node and branch this off at 1066, or excuse me, branch this off and run it at 160%. So what we know is that from 1066 to the end is what we want to retime as 160%, which is, by the way, it's noted this way at 1.6 speed, and I'm sure you figured that out when you saw me do it in this particular box as well. Now that we've done that, and of course we're going to set this to nearest to keep it so that we have no distortion happening on the plate while we retime this. And so then the next thing that we want to do is just set this to, let's see, yeah, we'll leave that alone. And then the next thing we want to do is actually set these so that they activate in the proper succession. So just going to write 160% so we know which one's which. And then I'm going to put a switch node in here. So with this, we'll start at 0 to the original. So that means 100%. And then for the 40%, we'll set that to 1. And then for the 160%, we'll set that to 2. So the next step is to go in here to the switch node, and let's just set it so this is 0 at 1023, and then 1 at 1024, and then at 1066, I believe. That's where it is input number 2. So it's just going to go from succession to real time to 40%, and then landing at 160% in the time base of the shot. Now with that said, you may be wondering why we're going to this extent, and oh, and mind you, I almost forgot, we need to add a time clip node to this and set this up so that this actually lines up at what do you call it, 1066. So we'll do that in a minute, but for the time being, let me show you why we are going to this extent, so there's a little bit better understanding. So I just did it like you might expect to do it, which is keyframing the speed channel on the retime node. Now if you look at this, if you look at my keyframes, so from 10 all the way to 1023 it said 100%, then we drop down to 40%, and we continue that to 1040, and then land at 160% on 1041. And the curve editor reflects this. So now that you see this, let's see what the output is. So I've actually flipbooked this, and this is it. So what happens is that for some reason Nuke does not have the ability to process this the way we would, like with a traditional editor in a timeline. So if you notice at 1023, actually here, let's just line that up with frame 1. So at 1023, okay, that's all good because it's 100%. But then as soon as we go to 1024, instead of holding to the next frame, which is 1024, but from there on out playing at 40%, it does that, but it actually jumps around in time. And so this is the reason. And then of course, as soon as we get to 1041, we set it to 160% and it's already disappeared off of the screen. So this is why we went through that whole extent. So now that we've done that, let's look at what the output is when it's actually done correctly. So here we have it now when it's retimed the way we'd expected. So if you notice, from 1024, it's, she moves a lot slower, and then she gets ready to jump, and then once she jumps, she flies out much faster. So this now feels a little bit more natural, like it's actually working like she was a fairy flying off. Now that we've done this, we now know that this is exactly the correct, how it's supposed to look in retiming. The only problem, of course, is that you can see, certainly with the slow motion, it's very stuttery. And then also, even when she pulls out, there's no motion blur. And if she was moving so fast, you'd have a lot more motion blur. So it doesn't feel quite so natural in terms of the retiming, but at least now we know where the frames should line up accurately in the timeline. So with that, let's go back to the script here. Oh, and one thing I wanted to mention before I close this panel down is that to set up the time clip, the first thing I did is just take this input range here, or the frame range, plug that in, and then plug in the original frame range so that way the media lines up with it. And then in the dope sheet, I just slid this down so that it lines up at 1066. And so obviously it goes beyond our frame range, which is 1077, but she's out of the shot by then. So with that in mind, let's go ahead and start adding some different retiming nodes like OFlow, for example, and Chronos to get better results and make this feel a little bit more natural in terms of how the motion blur and the smoothness is in the slow motion as well. So first thing first, let's go ahead and add an OFlow node. There we go. And with this, I suppose this was our retime that I'll leave this here just in case somebody wants to look at it, but this is the one that we did the keyframing on. So now with OFlow, let's take a look at some of the parameters here, and let's tweak them so that they line up with our collection of retime nodes here that we know is kind of our master layout for the actual retiming. So in order to do that, the first thing we need to do is take our method from motion, which is default, to frame. What this will do is it'll go to the nearest frame like we did in this collection of nodes. And the reason why we're going to do that is we're going to use that as our manner in which we can line this up to this as a reference. And then, of course, our reference will be here. So now that we've done that, the next thing that we need to do, by default, it comes into the in with the speed channel, but this time we're just going to go with source frame. And then we're going to add the various source frames. So this being at the first frame, and set them numerically so that they line up perfectly. After we do that, then we'll go ahead and switch this back to the motion setting and tweak some of these other options here to make it look better. So now that we've set the first frame, we know that the next one is, I believe, 1023 is what we know that that's going to be 1023. So that's real-time playback from here. And then the next one is going to be at frame 1066, right? Because that was the output of this node. So what we know is that we want it to come to 1040, I think. Let's take a look here. So this is the reference, and then this is our, it's close, but maybe, oh, you know what? It might be 1041, come to think of it. Here, let's see what that looks like. Yeah, that's it. Okay, so 1041. And then the last frame, which here we'll just do it this way. And oh, one other thing we want to do, by default this is going to be a smooth handle on the graph, but since we know our speed changes are abrupt, we're going to go ahead and break those handles. And so I'm hitting the L key for linear, and that's how we break those handles one more time. Now, okay, the last part is to see when she flies out. So let's frame this to the viewer and just see what the last frame is. It looks like it's 1077, but for all intents and purposes, let's go to 1076. And I think it was 1063 was the last frame. I don't know. We'll find out real quick here. And one more time, I'm going to break these handles. Okay, let's see. Nope, that's not right. But we can just hit the down arrow key here until we see the right frame, which 1057. Yep, that's it. Okay, so now we know that. And I think what I'm going to do is, just so that we know that the motion is the same, we'll just set a set the curve to continue linearly. So now it just continues on out of the shot in the right way. So now we have actually lined up the OFlow node to match up to the switch node in terms of the correct timing. With that, we can now switch this back to motion. So we now have a smoother looking playback as opposed to this here. But now that we have this, one of the things that we're going to end up with is artifacts. So let's talk a little bit about how we can make this look better. I believe I had earlier seen frame 1060 looks okay. However, you can see that we have a little bit of this tearing of the skirt in here. So that's one thing that we're going to have to be concerned with. And also it seems that it actually feels that the keyframes are not lining up quite right. Well, okay, they're close. So yeah, it looks like it's maybe just one frame off at any given point. Okay, so frame 1057. This is a great example of artifacts that occur when we use this vector-based retiming. So now that we have this, let's see what we can do to tweak these things, these settings here, to make it look a little cleaner. Now, admittedly, we're not going to get them completely clean, but we'll do the best we can. So the first thing that I tend to do just out of the gate is take the vector detail up to 1. I've found in almost all cases, just having this at 1 tends to take out a lot of issues around the tearing of the two different images. So where you have occlusions and things like that. And that's actually what we were getting with that skirt when we saw the skirt tearing. That was a result of those occlusions. And yeah, here it's a great example. So I think actually if we go back to the default, you can see right away that this skirt tears really quickly. So one more time, we'll set this back to 1. And admittedly, some of this is just not going to be possible to recover. So we'll address that towards the end of this. But then the next thing I tend to do is tweak some of the shutter time. So by default, it's coming in at 0, which means that it is not overriding the camera shutter. So if you look at this, it basically is, the idea is that it goes from 0 to 1, and that's 0 meaning no shutter angle open, 0.5 being 180 degrees, and then 1 being 360. So if we take it to 1, let's see what that gives us. Oh, and then what we'll need to do is actually adjust our shutter samples, so that way it has frames forward and backward to calculate from to create a soft blending of the motion here. So let's see if we can set that to 4 and see what that gives us. Now it's going to expand this a little bit, but that should be okay. And actually that looks pretty darn good. Admittedly, these things you just play with, and generally you're gonna you're going to get mixed results. Where you get benefits in one direction, you'll find that there are deficits in another. So it's basically trying to find the best of all worlds, and that's basically what we're doing here. Then the other thing that I might do is take the block size up. What that does is that basically takes the resolution that it looks at. It calculates less resolution in creating this motion blur, and when you have it at a larger setting, it's going to blur more of it, and it's not going to be as intricate. But what that means is that you're going to have fewer artifacts like this. So I'm thinking that I'm going to take this up to 10 and just see what this gives us. It may not work, but yeah, it looks a little better. There are some new artifacts in here, but to be honest, that might be okay for what we're going to try to do. And then we can try to play with the smoothness here as well. So if we turn this up, it should get smoother, but I found that you're going to have varying degrees of results as you increase this or decrease it. And this is one of those parameters that I tend to play with without, just seeing what the changes look like as we increment up and down. We could go all the way up to 1 and see what that looks like. And as you can tell, this is a heavy node. It takes a long time to calculate this stuff just for one frame. And we'll address that obviously down the line as well. So the smooth looks, now we don't have any artifacts, but of course now what we have is one big error where we're getting this gap, and we don't want that. So one more time, let's just see what happens when we start to adjust it down. 0.5 almost looked like it was the best. 0.8 looks pretty good. Let's see what see what 0.5 looks like. Honestly, not much of a difference between 0.5 and 0.7. Okay, well, 0.6 I would say looks the best, and this is just on one frame. As we start to look at different parts of the shot and different areas of time, we're going to find that the artifacts are going to be different and respond differently to the settings we've set. But I would say this is a good start, and with that in mind, let's go ahead and create a Chronos node. So Chronos used to be part of the furnace. Now with Nuke 7, it's its own standalone node that's just part of Nuke X, and I believe it comes in the time menu, which, yes. So whereas previously it used to be part of this furnace core, or in some cases the furnace, which these are the original furnace nodes, so you'll see that Chronos is here as well. And another thing to note is the new version of Chronos here is now GPU accelerated, so it's going to respond a little faster. I qualify that with the fact that it's still slow regardless, because it does have to go through an awful lot of calculations for creating forward and backward motion vectors. The same goes with OFlow. It's basically the same technology. The only thing really different is that the algorithm is different, I believe. So you're going to get mixed results between the two. One is not necessarily better than the other in all cases. So what I tend to do is precisely the same retiming with OFlow and match it with Chronos, and then use between these two, we'll select the better one and move forward from there. So now that we've done this, one of the things that we can do with we've created this curve, we can now just copy this. So if we go in here to copy animation, and we go back here to frame, we can now set this, where is it, frame, we can now paste this in exactly the same. So if we look at the two, you'll notice that there is no difference. It's exactly the same one. So now that we've done that, let's go ahead and look at the Chronos and see how it compares to OFlow. So if we view Chronos right now, just from this is in buffer number 2 is OFlow, and then buffer number 3 is Chronos. If you look at the two, you can see right away there's some differences, but of course what we have not done is set these things to the same. So let's go ahead and set the vector detail. Like I said, I usually set it to 1, and immediately we're getting something very different. But also, let's see, what would we set our smoothness to 0.6. Let's see if that makes anything better. And it doesn't look like it. Also, let's set the shutter. We have shutter time. We had it set to 1. And let's set our shutter samples to, what was it, 4? Let's see if we get something close between the two. So right away we can see that just with setting the same settings, we're getting different results. So let's start tweaking Chronos a little bit and try to make this look a little bit better. I think, given the fact that this is producing a fair amount of motion blur, that might be okay. So let's just go ahead and roll with that. And let's take our shutter samples up to 10. This will, of course, slow it down because now it has to calculate more, but let's see what that does. Okay, that does look better. We're getting less artifacting than we were before. Still quite a bit of artifact, but another thing that I like to do is I look at the various channels and just see where we can see big changes in luma values for each channel. And the reason why I look at this is that if we have like in the case of the blue channel, it's mainly uniform, except for the area outside of the in the matte area here where it's black. And that's actually good, because what we want is for it to look at it looks at contrast differences in each channel, basically color, and to determine the vectors on which way it's going. So I would say let's do this, set this to these tend to add up to 1, so let's do this at 0.3. We'll do the green at 0.3 and maybe the blue at 0.4, and let's see if that gives us any better result as well. Now, admittedly, these settings can certainly be tweaked, but that actually looks, it's hard to tell if it looks better or not. I can't remember what it looked like before, but it doesn't look horrible. So let's continue with this. And then there's one other thing that we can look at, but before I do that, let me just see what happens if we increase our shutter time. So now we're going to go well over a 360 shutter, so this is actually going to be artificial. It's not going to be mimicking or trying to recreate a real world scenario, and that looks worse. So we'll go back to 1. Okay. The other thing that we can do is take this overlay vectors, and this will show us what Chronos is seeing. So the red illustrates backwards vectors, I think, and the blue illustrates forward vectors. And this is, I find that it's not terribly useful knowing that and looking at it, but what I can see is that we can actually now, we can see how it's viewing the image, in terms of how accurate it's seeing things, but also once you click on this now activates this channel here, which we can adjust. So if we were to take this up to 40, it's going to reduce the resolution, and it might give us a better looking image because it's not going to be as heavy-handed in trying to calculate each and every pixel. But there again, that doesn't seem to be making a big difference. Let's go the other direction and just see what that does. And I don't know if you can hear, granted I'm once again working on a laptop, and you know they're big files, so it does take a lot of CPU power. But yeah, let's see here. Yeah, I'm not seeing too much difference in the vector spacing. So maybe we'll just leave that at default 20, because in the end, we don't need to make it work harder than necessary. And actually, come to think of it, I think I'm just going to set this to 40, because it means that it'll actually render quicker. So just because we weren't seeing any benefit out of taking the resolution higher in terms of the vector spacing, then there's no point in making it take longer to render and getting nothing from it. So I think at this point we've kind of exhausted what we can get out of Khronos, and that's okay, because this looks like it's going to be enough to work with. And so the next step with this, now that we've done these 3 different retiming methods, is to render these out as pre-comps. So we'll do that. But one last thing that I wanted to illustrate, there was a reason why I copied this green screen plate. And this is just to show you what happens when you have data surrounding it. So with this matte being pre-multiplied with the foreground with the RGB channels in this plate over here, it makes it a lot easier for Khronos and OFlow to calculate the in-between frames. When you have this green mixing in with it, well, now it becomes much more muddy and doesn't look nearly as good. So here we have, this is Khronos, and then here's OFlow. And you can see right away that, especially with OFlow, that having that matte and the pre-multiplication in there really makes a big difference. So that's the reason why I wanted to bring this up, is that knowing this when you're retiming stuff, if you do have a matte, if you can knock out, if you're doing stuff where you will be knocking out your green screen and so on, do this after you've knocked out your green screen and done the despill, because ultimately you're going to end up with A, better results, and B, it's going to render faster too when you pre-comp this out. And one other note about that is that in the Khronos specifically, you have this matte channel input, and this allows you to tell Khronos to ignore areas outside of the part that you want to be retiming, or basically you want to have it not calculate stuff that's in the background, because like you saw with the green screen, it's mixing in with the green material. Now that doesn't work as well as opposed to pulling your key and pre-multiplying it and just setting this to black. When you pre-multiply it, of course, it makes that black. So my point was really just, you have much better results if you do your key and treat your plate first, than as opposed to trying to pull a matte and run it into the matte channel. People do it with Roto, or creating keys and things like that, but frankly I have found that I really don't get much better results using this matte option. So that's why I didn't even go into it. So with that said, I'm going to go ahead and write these out as pre-comps, and we'll look at the 3 renders and go from there. Okay, we're back. So now that I've rendered these 3 out, I've checked the what is it, read from file? No, I haven't yet. So here, let's do that. Okay, here's that, and then there. Okay, so now that I've done this, we can flip book these. We've already seen the retime in the nearest frame, so let's take a look at the OFlow and see how that works. And when it slows down, it feels a little smoother. I gotta say though, at the tail end, right about here, it feels a little, you can see the steppiness of the shutter samples. So obviously in this case, what we will need to do is either increase the shutter samples, or we could just look at Khronos. One of the risks of increasing those shutter samples is that we might end up with it might be too soft and not feel very good as it does right in here. So, basically like I said, where you gain in some areas, you also lose and have some deficits in other areas. And then let's see what this looks like. Yeah, actually the tail end looks good. And the front, yeah, actually the front almost looks better. There is this artifact here that I can see right out of the gate. Not too many artifacts on this side that I'm seeing right away. But yeah, I would say this would probably be our predominant one. Certainly as it comes off, it seems to have a nicer feel to it. And honestly, you know, just from a stylistic perspective, what I might actually do is increase the shutter time in here, because that could actually produce a nicer fly off effect. So but that being said, one thing I wanted to do is introduce another way of flipbooking. So if you happen to have Hero Player and you are if you're in a facility and you have Hero Player and it hasn't been set up, I just want to show you really quickly as a little bonus how you could set up Hero Player to work in lieu of Frame Cycler. So let's take a look at that, and then we'll be able to kind of compare the 3 different clips that way. The first thing we need to do is launch Hero Player. So I'm just going to go ahead and launch this. What we're going to do is create a bridge between Hero Player and Nuke. So if you ever hear the term bridge, this is what we're talking about. So the first thing we're going to do is we'll start a new project just so we can open up Hero Player. Once we've done that, then the next thing that we want to do is go here to Window, and then here is where you set up your Hero Nuke bridge. So now that you have that, what we're going to do is install Nuke scripts. But actually, before we do that, the first thing that we need to do is just run one real quick check, which is to ensure that Hero Player is actually pointing to the right version of Nuke. So in my case, I have Nuke 6.3 also running. And since we're using Nuke 7, we just need to make sure that this is the correct application, which in this case it defaulted to it. I'm guessing it probably looks for the latest inline or latest release of Nuke to choose to create the bridge by default. But now that we've done that, we know that's good. And then, excuse me, then the next thing we want to do is click on this install Nuke scripts, and then immediately it says Nuke tools successfully installed. And then the next step from there is what we have to do is actually quit Nuke for what we're doing, because it has to reinitialize, or it basically needs to reopen, because what happens when you click this button here is it installs 2 folders in your .nuke, two files in your .nuke folder. One is the hero.py file, and the other one is your init.py file. Now you have an init.py file, but this I believe is an additional one. So when it sees a hero.py, it looks for another one as well that's in a slightly different location, if I'm not mistaken. So let's go ahead and launch Nuke one more time. And so now that we have this, immediately you'll see that we have a hero pull-down menu. And if you go here to connection settings, this will basically tell us whether or not we have the right version of Hero Player running, just like we did in Hero. This is now from Nuke to check to make sure that we have the right version, which in this case it's Hero Player 1.7 v1. And if we just hit this, let's also hit this here, which starts connection on startup. So now anytime you launch Nuke, if you have this set, it will automatically create that bridge. And I'm going to give it a second, so I'm going to stop for a sec. Okay, so I'm going to close this. Now that we have this set up, I believe it's active. So let me just open up the script. Okay, so there we have it. And now when we want to do a flipbook, so let's go to the This is the Oflow node that we were looking at. And here where you have this thing that says Frame Cycler, if you now go down to Hero, now you can launch your flipbooks in Hero Player, which is pretty cool. Now that we've done this, you can see right away we're getting the playback, and it actually, in this case, is actually playing back very quickly, which is great. And another thing that we probably want to do, since we're not working in broadcast, or at least I'm not, not on this anyway, let's set it to frames, so we can do that. But more importantly, if we go to preferences, I believe under, what is it, sequence, time display, there we go. Set that to frames and hit OK. So now whenever we pull clips in, it will default to the frames. And the nice thing is that just out of the gate, it gives us the correct frames. We don't have to do any tweaking or anything like that. So I'm kind of a big fan of Hero Player. And now I believe we I think we can open up, we can import actually. So if we go, this obviously hasn't been set up yet because we just started Hero Player, but I'm going to go ahead and set a couple of shortcuts, volumes being the first one, and we'll go to, actually what I'm going to do is go to the correct folder here. So let's see, I believe it's class 7, here we go, MD140, and then we have our pre-comps. So we just loaded up Oflow. So now we can load up Khronos, and we can also load up just the regular retime. The cool thing is now we can kind of go back and forth. So in our case, like from in the slow motion area right here, okay, this is good. So we're looking at Oflow, and we can see, and by the way, all the keyboard and mouse shortcuts, they all seem to translate from Nuke to Hero as well. Okay, so now that we have this, if we switch, we double click on here, we can see the differences between, well, it looks like it defaults to the framed view, but if you go back and forth, you can see right away the differences between the two. So in Khronos, we have this nicer motion blur, and in Oflow, we're getting, more defined lines, but it's certainly when she jumps out of frame, certainly here you can see right away that Khronos is going to look better, like I'm pointing out. And it's interesting because it's creating a wider motion blur in Oflow, and if you remember previously, we actually set the shutter time to be exactly the same. So this actually does illustrate how the two different operations, while they're using the same technology, actually have very different algorithms to creating what their final output. And then, of course, this is with the retime, nearest frame. There we go. For some reason, it was not functioning correctly. So this is with no motion blur, and this is with the Khronos motion blur, so it's definitely better. But yeah, now that we've done that, let's just to finish this out and let you folks get on with the shot, let's go back to Nuke and let's look at the next step. So we've been able to compare the versions now, and it's pretty clear that for the most part, I would say that Khronos is our main retiming method because it actually looked the best. So what we're going to do now is actually do a paint node, and we're actually going to use this to paint. We'll paint from the various sources here to fixing the artifacts, and this is how you go about using your best options in any given frame when you have to retime something. So if we go back over to Hero, I think, yeah, here, let's just, since we're looking at Khronos, let's, and I'm going to switch this back to the time. I think when we reopen, it should actually be okay. So now, when we look at this, we can see, okay, right here, what is this, frame 1057. We've got this nice artifact in here. So let's go over to 1057 of Nuke and go ahead and paint that out. Admittedly, we need to be looking at the right input. So here's our paint node out input. So if we, actually let's do this. Let's set this to the nearest. We're gonna just go buffer 1, 2, and 3, and then 4 for this. So now I can quickly go and look at each source. So with no motion blur, that's not very helpful. With OFlow, that looks pretty good, but it is actually a lot less, there's a lot less motion blur. So, but now that we see that, let's go ahead and try to clean up some of this. So let's, what we'll do is just take a, what do you call it, a reveal. And since we know that background 1 is coming off of OFlow, I'm actually going to do this. We'll break this away so we have more screen real estate. And we know that we want background 1, which is the input that we had previously for OFlow. And most of this is probably old hat to you now, since we went through the paint node and with quite a lot of detail. But now we can start to just clean some of this up, and this will give us pretty good looking playback once we paint these out. So now that you see what we're doing here, I don't know that I have to explain too much from here, because this gives us the options. So if let's go back here to OFlow and look at the output. So yeah, I can see right away we can sample some of this in here. And once again, I hear the machine going a little crazy, but that's okay. And here we can just kind of blend this off a little bit. That's okay. And actually that looks pretty good. So realistically, this is what I would do from this point forward. And with that, I'm just going to go ahead and paint this frame, leave it at this. And if you want, now you can see exactly how this works. If, say you come to a frame where neither Chronos or OFlow is giving you the result that you want. Well, this looks pretty good from OFlow, but here, let's go back to Hero one more time, and let's look at OFlow and see where we have an artifact. Well, we had one here, but we managed to work around it. Okay, here we go. Oh, here's a really good one, actually. Okay, so frame 1050. So we'll go to 1050 and look at this one. So looking at, well, actually, Chronos isn't looking so bad on this frame. I guess I'll just explain it. If you have a situation where both Chronos and OFlow are not working quite right, but for example, OFlow is giving you a better result, you can then just switch over to clone. I mean, I don't know if I needed to explain this, because I'm sure you could have figured that out. And then you can just clone off of the, you know, you can reveal from the OFlow if you wanted, and then adjust it just by cloning back some of the OFlow to kind of make it blend in a little bit better. But honestly, I guess that wasn't necessary to explain, because I'm sure you already knew this. So anyway, that essentially wraps up this class. What I would say, if you could do this, is go ahead and retime. Well, two things. Decide whether or not you like this retiming. If you want to change the retiming entirely, I say go for it, because you don't feel that it looks as natural as what I just created. You know, my feeling is experiment, be creative, try some other stuff. Then more importantly, I would say retime this one first. So Now that we've done this, go ahead and finish out the paintwork for the frames in Kronos that are bad, and sample from the nearest if you need to, and also from Oflow, of course, because that's the default. And just paint out the artifacts as you see fit, and then you can render this out and see how that looks. And then once you're done with that one, go ahead and attack this one. So then we actually have a pretty good looking system for the two. And then next week what we're going to do is we're actually going to add some CG wings to these two characters. So if we look at this output here, we'll have wings that are applied here that were created in CG, and we're going to go through just basic integration of CG, and then also take a brief look at the relighting functionality of some CG passes. So we'll do that next week, and then that should wrap us up on this shot here. So anyway, thank you very much, and by all means, please let me know in the forums if there's anything that you'd like me to speak more about, or if you have any questions, because I will definitely respond. So thanks again. Have a great day.